The measurement will be made by using with the two conditions. One is at a constant volume as well as with a constant pressure. The change in internal energy at a constant volume. So this was done by using what? Warm colorimeter. Thermochemistry is a branch of chemistry which deals with the heat changes during the physical and chemical transformation. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we have discussed about the application of first law of thermodynamics, and also we have discussed about the enthalpy, heat capacity and the relationship between the Cp and Cv. Today, let us move on to the next topic of this unit by understanding the measurement of the change in enthalpy and change in internal energy. And we are going to discuss about the thermochemistry, the enthalpy change for the reaction and standard enthalpy of reaction and standard enthalpy of formation we are going to understand in this session. So, firstly, we will see how we can measure the change in internal energy as well as with a change in a enthalpy. So that can be measured by using a different experimental technique. So first is by using calorimeter. By using calorimeter, we will see how we can measure the change in internal energy as well as with a change in enthalpy. An experimental technique that used to measure the energy change associated with a chemical and a physical process are said to be a calorimetry. So, by using this calorimetry, we can clearly understand during the physical and chemical process what is the energy which has been associated, that gives a clear information. And in calorimetry, the process will be carried out in a vessel called as calorimeter, and which is immersed with the unknown volume of the liquid with a known heat capacity of the liquid, in which colorimeter will be immersed, and the heat capacity of the colorimeter, it is possible to determine the heat which has been evolved in the process by changes with the temperature. So the measurement will be made by using with the two conditions. One is at a constant volume as well as with a constant pressure. So more about this, you will understand by taking with the bomb colorimeter as an example. So this is a complete figure about the bomb colorimeter, where you are going to measure the heat change at a constant volume. So you are going to measure what? The change in internal energy at a constant volume. So this was done by using what? Bomb colorimeter. So for a chemical reaction, the heat is absorbed at a constant volume which has been immersed in the bomb colorimeter. The steel vessel will be immersed in a water bath, and which ensures that no heat which has been lost during the surrounding. So this is a figure about the bomb colorimeter. You can see that this is a steel container. Okay, this entire purple color is a steel container, which is also known as what? Steel bomb. In this steel container, they have kept a crucible which are having a sample. To this sample, they have introduced the electrical ignition wires, okay, which is also known as what? Ignition coil. So through this, they'll apply the electrical field so that the combustions will be happening. You can see that the steel bomb will be immersed in an water bath. Meanwhile, the temperature will be noted by using a thermometer. So during the combustion processes, you can see that during this combustion, whatever the heat changes which has been taking place, that can be absorbed by using a thermometer. Meanwhile, take an help of the stirrer so that the constant heat evolution with the entire container will be done. I'll explain once again. So this is a picture of the bomb colorimeter, where it has a steel container which has been kept inside this colorimeter, and inside this steel bomb, they have kept a crucible. Inside this crucible, you can see that this is a sample. Okay. To this sample, they have introduced the ignition coil, and they'll through this ignition coil, they'll apply the electrical field so that combustion of a substances which is taking place. Meanwhile, they'll keep this entire steel bomb with a water bath so that they'll measure the temperature differences at the initial of the ignition as well as at the final state of the ignition. So, meanwhile, whatever the oxygen which is required for the entire combustion of the sample, that can also be supplied. So, this is the entire figure about the bomb colorimeter. So, after the entire combustion of a sample with the presence of an oxygen, they'll measure the change in internal energy of the system by keeping the volume constant. That is why, they'll use this steel bomb colorimeter to keep the volume of that entire process at a constant phase. So, hope you all understood with this. How does they'll measure the change in internal energy by considering with the steel bomb colorimeter. Since steel bomb colorimeter is sealed, the volume will not get disturbed and it does not get changed, and that can also be calculated by using this equation, that is Q is equal to C into M into delta T. C is a specific heat and M is a mass of the substance, and delta T, which is nothing but a change in temperature. So, before the combustion, what is the temperature? After the combustion, what is the temperature? They'll take the differences of these two and they'll put the values of delta T, that is change in temperature. Next, we have this measurement of change in enthalpy. The measurement of the change in enthalpy will be done by putting the pressure as constant. Okay. So, this can be observed by using this colorimeter. Okay. The measurement of the heat change at a constant pressure can be done by colorimeter. So, we know that delta H will be equal to the Q, that is at a constant pressure. Therefore, the heat is absorbed or evolved at the applied heat at constant pressure. It is also known as delta. It is also known as the heat of reaction or enthalpy of reaction, and it can be written as delta RH. So, for this, they'll use a specified colorimeter. You can see that there is a 2-cup styrofoam cup will be introduced. Inside the one of the cups, they have taken the reaction mixture and also they have introduced a stirrer along with the thermometer. So, during the complete reactions which is happening, they'll measure the thermometer, they'll measure the temperature with the help of the thermometer. So, here they will keeping the pressure as constant, so that delta H will be equal to the how much of the heat which has been supplied to the system. Like this, the changes in the enthalpy can also be measured by using the first law of thermodynamics by using what? Colorimeter. So, remember, we are using a different types of colorimeter. One is bomb colorimeter as well as with a colorimeter. Bomb colorimeter will be used to measure the change in internal energy, whereas a simple colorimeter will be used to measure the change in enthalpy of the system. Next, we have thermochemistry. So, while dealing with the thermodynamics chapter, we have understood that what is actually a thermodynamics, which talks about only the states of the system, that is whether the reactions which is at which stage it talks. Then what is this thermochemistry? We'll see now. Thermochemistry is a branch of chemistry which deals with the heat changes during the physical and chemical transformation. So, it talks about the heat changes either if it is a chemical process, either in the physical processes or in the physical transformation. For this, we go with the thermochemical equation. We'll see what is a thermochemical equation, because we know that what is the equation, because in chemistry, equation in the sense where there is a reactant which is giving rise to the product. Correct, no? Then what is thermochemical equation? The thermochemical equations are the balanced chemical equation in which the delta RH during the reactions and the physical state of the reactant and the product will be indicated. So it is not just a reaction between reactant to give a product. The reaction must be balanced and the reactant as well as the product state we need to represent. In the sense, what is the actual state of the reactant, whether in the gaseous state or in the liquid state, either in the solid state, we need to measure it, and this reaction must be balanced, and for this reactions, we need to represent the change in enthalpy. The best example is carbon and oxygen, which is combined to give a carbon dioxide. You can see that carbon which is in the solid state, oxygen which is in the gaseous state, which is giving this to the product which is in the gaseous state, and this reactions which is also balanced, and you can see that delta H for this reaction is around minus 393.5 kilojoules per mole. This is how we can write the thermochemical equation by looking at the reaction, whether the reactant which is present in which state, whether it is balanced, whether the change in enthalpy is written or not, we can confirm it and we can write it as a thermochemical equations. Next we have the enthalpy change of the reaction, which is also known as what? Reaction enthalpy. The enthalpy change during the reaction, which is said to be what? Reaction enthalpy, and the enthalpy change for the chemical reactions will be given by a symbol known as delta RH. Okay, so this can be calculated by using a formula, that is, the reaction enthalpy can be calculated by using sum of the enthalpy of the product minus sum of the enthalpies of the reactant. For example, if I take the carbon and oxygen is giving rise to the carbon dioxide. So what is the enthalpy of product? So enthalpy of product minus enthalpy of reactant, sum of the enthalpies of the reactant. Like this, we can measure the reaction enthalpy. How does the reaction enthalpy will be obtained? Reaction enthalpy will be obtained by sum of the enthalpies of the product minus sum of the enthalpies of the reactant. For example, if I consider the carbon and oxygen is giving rise to carbon dioxide, this is my product and this is my reactant, correct? No? So enthalpy of the reactant minus the sum of two reactant, which you minus to get a reaction enthalpy. So reaction enthalpy is equal to enthalpy of product minus enthalpy of the reactant. Next we have standard enthalpy of reaction. So how to maintain the standard enthalpy for the reaction? The standard enthalpy of the reaction is the enthalpy change for the reaction when all the participating reactant substances in their standard state. How we can represent that? The standard state of substance at the standard state of a substance at the temperature around 298 Kelvin and in a pure form pressure around 1 bar. So if you are writing a reactions, if it is in at the standard state of enthalpy, we always represent with the symbol known as delta H naught. So delta H is a change in enthalpy. If you wanted to present in case of standard form, we write it as delta H naught. Why it is H naught? Because it is a standard state where the reactant in a product which is maintained at a particular temperature as well as at a constant pressure. Okay. Next we have standard enthalpy of formation. The standard enthalpy change for the formation of 1 mole of a compound from its element in their most stable states are known as standard enthalpy of formation, and it is written as delta F H naught. For example, you can see that carbon and oxygen which is giving rise to carbon dioxide. These two are the reactant. One is present in a solid and one is present in the gaseous state, which is giving rise to the product which is at the gaseous state. So this is how the enthalpy of formation of the reaction can also be written in the standard format. So in the next class, we are going to discuss with the enthalpy of different types of the reactions, and I'll come back with the next topic. Till that, take care, be safe. Thank you.